Hello, this is Dean Tribble. I am CEO of Agoric. I want to welcome you to our DeFi Legos in JavaScript, talking about our technology, blockchain, and components, all built using Tendermint. I have with me, you'll hear the magic voice in the background, Kate Sills, who is also one of the magic developers in the background that made the stuff that you're going to see possible. So I'll be talking about how to do DeFi Legos in JavaScript for the Hackathon 5 workshop. So I'll be introducing our Cosmos SDK-based zone to be able to produce smart contracts rapidly built out of other components. And I should warn you ahead of time, this is welcome to the bleeding edge of DeFi technology, to the frontier, not just of finance, but of development. We are built on Stargate 0.4 or 0.40. We are in alpha with technology that will enable you to rapidly produce things, but it is new and novel and could have the typical alpha issues that we will leap on to the best of our ability to smooth your way to building DeFi dApps in this hackathon. It has additional technologies like state sync and IBC and various things behind the scenes, especially IBC you may choose to leverage in order to tackle the prizes coming up in the hackathon here. Now, this is a hackathon, right, with 20,000 in prizes. The primary value that we can bring to you and the reason to go out to this frontier of technology is the ability to rapidly produce exciting, interesting DeFi applications and take over, using the Agoric SDK and capture that Gringotts Award. We have confirmed that it's on the table for us, and you can use these tools to be able to help get there. Okay, if you need help during the workshop, we will be in the Discord channel in Cosmos for the Hackathon 5, and there'll be plenty of Agoric people around there. We, of course, have our own Discord, but there'll be office hours and sort of continuing availability. During this talk, please post your questions to the YouTube channel. They will show up here, and I'll be able to see them, or Kate will leap on them, or other people in the channel may respond as well. Okay. So I will give you an overview of Agoric. We'll talk about some of the DeFi Legos, and then we'll dive into a demo of dApps built with them, look at the code, look at more code, and finally let you all off to go and hack on the technology. So first, let me say a little bit about what Agoric is and what Agoric is doing. So we all know as the next generation, the frontier of finance, DeFi is, like any frontier, exciting, but quite dangerous at this point. Existing systems have poor performance, whether it's volatile gas prices or slow finality. Some of these are addressed, for example, in proof-of-stake systems like Cosmos, but they have some of their own challenges with economic pressure towards centralization and hard to extend with staking derivatives and that sort of thing. Now, in Cosmos, we have the unified DAO. We have a big surge of activity to be able to tackle these things, several projects working on integrating staking derivatives. But even once you get there, you need an economy in which to trade them. You need the markets in which to be able to price them and that sort of thing. So we need not just primitives to extend the system, but we need the ability to grow an overall infrastructure and market around this stuff. We know that especially in Ethereum and in other systems, the developer experience is pretty rough. Not just that the tools aren't quite there in a bunch of these systems, but the model of programming has intrinsic security hazards where even experts get it wrong and lose tens of millions of dollars in minutes with no recourse. And then finally, those same security models result in poor composition. It's very hard to take one component and reuse it in another. Now, it's exciting that the speed of innovation, the speed of iteration, the speed of rollout. It used to be that it took years to build a new DeFi product and start rolling it out there. But most recently, with, for example, Uni rolling out, that took, instead of years, instead of months, it took literally weeks for them to produce this important new innovation. And they did that by being able to take an existing component, the the governance token from Compound and copy it and combine it with their stuff to produce a new offering. And that's very exciting. It was clearly very valuable. It was clearly a big step forward. But remixing source code, code copying, what we used to do before we had real composition, is risky. And so, for example, lendf.me, they did something very similar where they took Compound source code for governance, they integrated it in, they rolled out some new products, and the resulting composition had a bug that lost them $25 million. Right? So it's one of those things where, yes, innovation is crucial. We need rapid time to market, but we need safe ways to rapidly compose new systems. I see people saying hello in the YouTube. Hello, everyone. Welcome. And as questions come up, as I said, we will respond to them. Okay. So what's Agoric doing? We're building infrastructure to be able to accelerate DeFi and accelerate it safely. So it's a layer 1 chain built on Tendermint using Cosmos SDK, using, in particular, our alpha system is using Stargate. Because a big part of our development work, as many of you know, is driving IBC and dynamic IBC and making it available inside of our smart contracts and inside of JavaScript. We have predictable gas economics. You don't need to care about that right now. It's built where you can build smart contracts in a familiar programming language. 80% of the programmers on the planet know JavaScript. And in particular, you can build with familiar abstraction patterns, familiar techniques of programming from Node.js, from browser applications, from React, from all of these frameworks where 15 years ago, to build a UI, an expert could cobble some things together. But now, a relative beginner can grab, a picture carousel and a shopping cart, plug them together, and produce a better application for selling art images than an expert could have done 15 years ago. And that's because they're able to take existing objects, not by copying the source code, but by taking the objects, npm install, whatever it is, and plug them together in order and put their own shape and framework and add their own expertise to deliver something that built on other people's expertise, combined it with theirs to produce something new. That's real composition. We do that for DeFi components. So we provide that for market components, which we'll go into, we'll show some of here. And we then integrate those into the platform, into the blockchain that we will be building, the blockchain that we'll be rolling out next year, so that the staking infrastructure uses the same smart contract infrastructure. Smart contracts execute where they can pay for gas using a local currency, a local stablecoin. There's AMMs integral so that loans get liquidated automatically. All those kinds of things that will make it easier to build and roll out components that work with each other with consistent pricing, with the ability to sell to each other, with the ability to have comparable products from different smart contracts in the same markets and so forth. And so those are a bunch of the initial Legos that you can both start with and build upon and add to extend the system with your own components and use those components to build new DeFi applications. So that's the goal. That's why we're here and providing a tool you can use to tackle some of these challenges. Okay, so I'll say a little bit more about the stack, and then we'll go into more of the code to be able to drive this. So at the bottom, of course, there's Cosmos, Tendermint. Above that, we have a Cosmos SDK plugin that launches our environment. So it's the Agoric VM. Some people may have heard of it referred to as swing set, that provides not just on-chain execution, but consistent execution for your off-chain cloud things to be able to connect to on-chain contracts. And it provides confined secure execution of independent JavaScript contracts so that with asynchronous communication between them. Now, when I mentioned before that, what was hard 15 years ago, now beginners can do, that's because not that they had more low-level stuff, but they had libraries and frameworks. React is my favorite example because literally millions of programmers ramped up on that very quickly, where it's not just a bunch of components, but it's also a framework for being able to plug them together. Standard interfaces, standard elements that you program to. So for us, that's electronic rights transfer protocol. Now, let me step back for a moment. So Agoric, the company, was founded by pioneers in the space of smart contracts. So Mark Miller did the Agoric Open Systems papers back in 1988. I worked on and the Agoric Open Systems papers describe software agents producing, creating and participating in markets automatically. It's a pretty common element of the crypto canon for people to be aware of. Indeed, there now, is a series of Reason videos providing a documentary about the work that led to that and about the first production smart contract. I worked on the first production smart contract. So we've been working on this stuff for a long time. And out of that have evolved some of these reusable abstractions that we're going to show you. The electronic rights transfer protocol is not a crypto protocol. It is an object API. It's a set of abstractions so that you can build new components, just like React or Vue are sets of abstractions, so you can build new visual components. This is what lets you build new market components, new economic components, and plug them together smoothly. Zoe is then a framework in which you can glue them together and have them use each other safely so that I can, as a client of a dApp, execute it safely. And we'll talk more about that. And finally, then, there are all the components that we built, like covered calls and atomic swaps and so forth. And we'll see some of those. Oh, and I should remind you again, this is all well into the experimental thing. They've wanted us to be very clear, right? The hackathon, a big chunk of it is using the production version of Cosmos SDK to build towards production apps on the current networks. The Stargate upgrade is a huge, important, valuable upgrade that will really move Cosmos forward. We're building on that, but you should consider, if you're building advanced DeFi, build on our stuff for these things. Take leap towards where the technology will be going in the next couple of months. But if you're planning to roll out soon, well, you might want to use the production APIs. Okay. All right. So let me say a little bit more. I mentioned the ERTPs, and I'll refer to the issuer kit, where a kit is a set of different objects you can use together. So these are the concepts with which we produce our components. And some of them and they're very simple, and they're very familiar, but where the lines are drawn makes a big difference on how easy it is to compose new abstractions. So purses are the moral equivalent of accounts. I can have a purse of ETH, a purse of atoms, a purse containing baseball cards, a purse containing remote currency from some other blockchain, whatever it is. It's a container of a particular kind of thing, a particular kind of asset. A payment is something I would withdraw from a purse in order to transfer an asset, right? The purse is my privately held, closely held assemblage of that stuff. I can withdraw a payment, I can transfer it. And it has all the object protocols to be able to participate with the other objects here, so I can claim, so that when I transfer a payment to you, you can claim exclusive access to it, verify that it's the correct thing, and so forth. Mints are, for a given type of digital asset, they are the things that can make more of them. If I have a type of asset where I allocated 50 million and then I'm done, I just do that by throwing away the mint, burning the mint. But if it's something that could be issued over time, I would have a smart contract that holds a mint. Anytime the smart contract wants to issue some new fungible or non-fungible token, it uses the appropriate mint that it's holding onto and says, mint me a new payment that now produces a new set of tokens for that particular kind of digital asset. And then finally, an issuer is the abstraction that goes along with a mint, where a mint can create items and must be closely held. The issuer is broadly advertised and made available so that anyone, when they're presented with something that claims to be a payment of these collectible magic items or these wrapped Bitcoin tokens brought over via Peggy, this issuer can verify it and enable you to claim it and get exclusive access if indeed it is the asset you are looking for. And then finally, all of that is held together with two little elements of abstraction. One is a brand, which functions just like a brand in the rest of the world. Dollars are different from euros. Well, the brand is the thing that says this is dollars, right? It is the label dollars that you can't forge. It's not just the word; it's the ability to have an unforgeable reference that says, this is what we mean by atoms brought over the transfer from IBC. And then finally, amounts, where this is how it's like denoms, right? This is how you describe not just a fungible token, not just 20 atoms, but the set of baseball cards, including these 3 collectible ones. Okay? And then behind the scenes, there's math and tools in JavaScript to easily be able to manipulate and compose all of these. Okay, and then out of this, we build these DeFi Legos, right? We build components for these. So the first set of these, the first 4 that are in bold, right, come directly from ERTP, right? They're the purses. I just have an object that I can do withdraw on, I can do deposit on, I can take up, and I have the payments where I withdraw a payment in from one purse, I deposit it into another. They have the fungible tokens and non-fungible tokens that are simply the things produced by mints. If I've got a mint for currency, I mint it, I get new fungible tokens in that currency in the form of a payment, I can deposit it into the person, they all play well together. So those are sort of the starting points, the axioms, if you will. All the rest of these here are smart contracts built as separate running programs in JavaScript running on top of our platform. So we will be showing the set of smart contract components and applications on the left. The Agoric SDK, that if you followed the instructions at the beginning, the Agoric SDK includes several of the ones on the right. Some of them we are in progress of building or have spikes or early implementations like the stablecoin or voting abstractions. But those are all the kinds of reusable components that are in development and that apps will be able to use, or you as developers could create and contribute for other applications to be able to use. Okay. So let us dive into some code, right? So you can see here I've got references to these. Someone will post that into the YouTube channel, and we're going to look at a simple contract for fungible tokens, for being able to get them over a faucet. And then we'll look at a card store application that combines those. We'll then go into a few more principles and then come back to look at more complicated code like the OTC does. So let's go ahead and jump over to there. So this is a standard, one second. So just a quick question. Are people putting things in the YouTube channel? I want to make sure that I'm seeing these comments and questions. So I think I'm not. So Kate, jump in if there's a question that I should stop and answer. That'd be great. Okay. Let me see here. All right, so what we're looking at here is the contract for a particular application. Now, in the instructions, we talked about how to go in the setting up instructions. You might have arranged for getting your own dApp, and it starts with if I go to those 2 URLs I showed you. Here we go. This is the card store, where at the fungible dApp. I will zoom this in just a tiny bit. They're the set of things I go through where I do Agoric init of the dApp fungible faucet. That's up in this repository in GitHub. Most of our components are all open source. And when you do that, it's like doing a template install in Vue or React or Ruby or what have you, and it produces a local directory tree with a contract directory, an API directory for your cloud services, and a UI directory with an initial UI. Okay, and so you can see in here I've got VS Code, standard VS Code with command line windows on the right, and with and here you can see I've got a contract directory, an API directory, and the UI directory, and I can go ahead and go down there and look at the source code, and I am looking here at the contract for the application that I am about to show you. So I'm going to, looking at these instructions, I need to do an Agoric install, which I already did, but it doesn't hurt to do it again. You'll see that now in our current environment, in our current alpha, in our current alpha, you install the Agoric SDK just like you'd install the Cosmos SDK. Agoric SDK includes all the packages it needs from Cosmos. And so that we can rapidly iterate, you can sync up to the latest updates on the SDK. There will, of course, be a package style installation in the future, but as we said, this is out in the frontier of working on this technology, and so that's the right place to start. I will now reset my chain. Ooh, I'm gonna open up a YouTube window just in case, so I can see all your questions here. Okay. And I'm just popping out the chat here since I wasn't seeing it in the other window. Now I can see a little bit more of these things. Great. Okay. So I'm going to reset my chain and then wrong app here. And start up the chain. So Agoric start dash reset starts up the chain in a blank slate, and then I'm going to go and deploy the application. Right. So right now I'm going to start reset the chain, and in this scenario, let me go ahead and make it slightly bigger. You can see that I've started executing the chain, and it's now running in this window. I will go over to this window. I will execute the two deploy commands, and they will wait for the chain to start up. They will connect to it, and they will deliver the source code of this contract here up to the chain and install it. I will then run the API script that will connect to a API server, effectively deploy a cloud server, if you will, and install my cloud application as a web front end, as an API server front end for the chain, where it has secure connection over something that currently is just similar to IBC, but eventually will directly be IBC into the chain sample. Now, here I'm doing this all as a local execution. All of this works also working up to our testnet. But here it lets me do local debugging, so I'm entirely running this on my machine right up here. I can end up connecting my debugger, stepping through it in a normal debugging environment, and so forth. The next step is go to the UI directory and start Yarn. I already did that here, so that Yarn is starting. So now I will go to this URL and take a look at the application. So it's right here. You can see I have it's asking me to go to my wallet. And in my wallet, I will start up a new browser. I am, unlike many of you, I am in using a Linux under Windows, so some things don't quite automatically work as well for me as they will for you in the normal thing. Okay, so this is a web-based wallet. Up here I have the set of offers that applications have made to me, like do I want to make some trades and you'll see that throughout this. Here I have the set of applications that have tried to connect to my wallet, in this case the Fungible Faucet application, and I'm going to go ahead and give it permission. So now the Fungible Wallet application is connected to my wallet here. In the lower right, I have the set of purses that are available to me, my private stash of purses inside of my wallet. And when I approved this wallet, it went ahead and added a purse for the kinds of tokens that the fungible token faucet provides. So now what I can do is I can go back to this fungible token faucet, and it says, hey, just go ahead and mint something, right? Now what that does is if here this dApp connects directly to my wallet and says, I've got an offer that you should approve. I'm suggesting that you make an offer to the contract on the blockchain of the following form. And I'll talk a lot more about offers in a minute. But in this case, the offer, since it's a faucet, is, yo, I want 1,000 tokens. Just give them to me, right? I'm not going to give you anything. I'm not going to pay for it. I just want you to send me that, right? So yes, I'm in for that. In my wallet, I am now approving that it should be able to, it should submit on my behalf to this contract an offer that says, hey, could you give me some money? We'll see fancier offers in a moment, and you'll see why all this mechanism works. And now that I did that, behind the scenes, the contract all executed, and I have 1,000 tokens in my wallet. So I have 1,000 tokens that I just got from the fungible faucet. In case you missed that, I'll do it again. Here's an offer. I'm demanding another 1,000 tokens, and now I have 2,000 tokens in my wallet here. Okay, and these are fungible tokens. Let's look at how that was done. Okay, so let me jump here, and of course, having brought up the chat window, it then immediately vanished behind all of these other windows. Isn't that the way that works? All right. So the way contracts are built in Agoric, it's in JavaScript. It's just a module written in JavaScript using very familiar tools. So this is a standard VS Code, with lint rules and automated test running and normal debugging and all those kinds of things. So for example, if I hover over this, it says it's a contract facet. And if I were to start saying, make mint, it's got normal command completion and all the types of the arguments and all those kinds of things, right? It says, I want an offer handler, I want all these things. Okay, wait, that's not what I wanted to do. I wanted to do, a mint. All right. Okay. So in JavaScript, to input in Agoric, a contract is expressed just as a JavaScript module with a function, with a single start function in it that is exported. And the start function takes as an argument an object we call the ZCF because it's cool. It stands for the Zoe contract facet, and that is the contract's access to the internal contract infrastructure that's operating in. So through that interface, it can ask about things like, what are the state of offers? Who are the people that are trying to do business with me? What are my accounts? What are my internal assets? And that sort of thing. So the first thing it does is I'm starting up the contract, is it creates a mint for my new tokens, right? That's what it takes to now make a new non-fungible token. If I wanted to make fungible tokens, well, you'll see a similar one-liner later. Maybe it's 2 lines, right? But now I have a new mint where the operation to be able to generate brand new tokens for this, for this kind of token is going to be, it's right down here. It'll be mint gains, and we'll get there. For this mint, I am now also going to pull out the record of the other pieces. So I'm going to get the issuer, which I can then hand out publicly so everyone can verify that if someone minted tokens and sends it to them, it's the tokens that they intended. And we'll post the links. I noticed the links are being blocked in some of this in YouTube. They'll be posted in Discord for the hackathon Discord as well, which everyone here ought to be in as well. Okay, so I get a mint. From the mint, I will get the issuer record so that when I start to mint tokens and send them out, everyone out there is able to verify that indeed they're getting the right kind of tokens. And then the fundamental thing that this smart contract does is it's going to mint payments, right? That's what I want it to do. Well, that's just a JavaScript function that for a given, I'll talk about seats in a moment, but for a given request to mint payments, I'm going to decide I'm going to mint 1,000 of the tokens associated with this mint. Okay, let's talk about that for a moment. It's not I'm going to mint 1,000, right? Money and finance doesn't work that way. I don't go to a brokerage house and get 1,000. I get 1,000 Apple shares, or I spend $1,000, and $1,000 is different from 1,000 euros. It's crucial and important that contracts be built so they're not just floating around numbers, but rather we are clear about what they are, and it's easy to verify that when someone sends me a description of something, it is the something I wanted. It's not 1,000, it's 1,000. Of these tokens issued by this faucet, because that's what some other contract is going to want. And I want to be able to have all of my contracts working together where they automatically and easily verify that they're getting what they expect. And we'll talk about that, how that happens later. So here, this amount math is the amount math for these tokens. And indeed, maybe we want to make that more clear here. Let me go ahead and use the standard kinds of mechanisms in JavaScript to be able to make that clear. I'll go ahead and rename that, and and it gets renamed in all the appropriate places. standard kind of bar that people expect out in normal application development world. So now I can ask that tokens math, make me a tokens amount that describes 1,000 of those tokens. So it's not that it minted it. Now we're just being clear that we mean 1,000 tokens. Then it goes to the mint and say, hey, you have the only authority in the world to be able to mint these tokens. Please mint those tokens, and don't just give them to me. Attach them to the seat of the request coming in. So requests come in, their offers. The way I reference them inside of this handler here, this is a handler for offers coming in, is I get a seat that says, here's the object that has all the assets that they offered, and that you sort of arrange to describe what happens. We'll see a little bit more about that later. What this does is this mints new tokens, attaches them to that seat, exits the seat, so it just goes ahead and pays out those tokens to the guy who requested them, to the purse or other contract that requested them, and then it's done. Offer's completed, right? So it really is, take an amount, mint it, and you're done. That's kind of what you would expect out of a faucet, right? Now, what to put the rest of the contract together, this contract was created by someone. They get privileged access. So that privileged access is the facet that will be returned to them, that they get access to, that they can then decide, how do I want to publish this? Who do I want to make it available? That kind of thing. So they have the ability to construct invitations. If we think about a contract, like if we think about an auction, a smart contract, a smart contract implementing an auction, there's a table where the person selling comes and they brings their good they're going to sell. The bidders come and they bring they get a seat at the table, and now they can bid. And the bidding happens until we're done, and then they all leave and they get their payouts. The winner takes the new goods, the seller takes their money out. That's why we use the term seat, where that's that is the object that references your access to the current stash of things you are participating in this contract with, and dickering with the participants, or have an order on the order book and what the status of it is, all those kinds of things. So in order to participate in a contract, you get an invitation. So here the creator has the authority to make invitations that they can hand out to people to go and demand payment and mint a payment on this faucet. So, and we'll see a little bit more of that later, but that's what the creator's able to do. And then the public facet is everybody, once this thing is available, everyone with access to this contract at all in any form is able to get to the public facet and get that token issuer in order to find out, in order to be able to verify, for example, if through some other path they got tokens, they want to be able to verify that those tokens are actually from this issuer. They're not Bitcoin Classic, they're Bitcoin Lite, or vice versa, right? Okay, and then the contract returns those two objects, the creator facet and the public facet, and we're done. That's the entirety of this contract, right? Now, it's got a lot more comments, and it's got various checks, so it's a little bigger than it would have to be in order to be clear, but that's the entirety of this contract. Public access to find out what type the money is, private access to be able to construct invitations, so you can invite anyone to the facet that you would like to. Okay, and then we can go through more of the UI, and we may do that later, but that's what's going on here. Let's look at a slightly fancy. So first off, any questions? Let me take a quick look over here. But otherwise, we're going to go into one where you start to see where these pieces work together. So these little wrinkles like offers and seats start to make sense. All right. So what I'm going to do is I'm going to go to another application, the other one that I mentioned, the card store. Okay, so the card store is a demo where you'll see it in just a moment. Let's assume you installed it. You can look at that link. We can paste that command string so you could do the install locally. That would create a local installation. Now here it says do the Agoric install. In my case, I've already done that, and start the chain. I'm not going to do that because this would start another independent local chain, and to connect them, I'd have to then do IBC and a bunch of things that are out of the scope of this. Instead, I'm going to go ahead and, it's a chain. I've already got one running. It's running in the local machine. I can have debuggers and all that sort of thing. I'm just going to go ahead and deploy to that, right? So what I'm going to do is I'm going to go to my baseball card application, and I'm going to go up here is where I did the install, go down here, and I'm going to go ahead and do the deploy of that contract onto the very same chain that is still running. Okay, and then I'm going to deploy another cloud server. It's configured to sit on another port, and it will be running. You'll note that it is on. It'll be running on port. I've already got its UI started, and so that's running on port 3001. So let's go take a look at that. Here is, and I can refresh so you can see that it is the right thing. There we go. And it too, right, it wants me to go to the wallet, the very same wallet I already had up. You can see that there's the fungible faucet, and now here's this other application, the card store, that is trying to get connected to this thing. Now, rather than my digging into this, I think there's a story behind this card store, but let me go ahead and enable it. Can we hear Kate's voice? Are you in the channel here?
Yeah, I'm here.
Excellent. So you built this application in a day. You built this, I think, yesterday. Can you tell us about the background and then I'll go into the code and you can walk us through it.
Sure. So this started from an idea. There was a video game, I think in the 80s, where they had to make up the names of baseball players. And so I thought those names would be fantastic as example baseball cards. And there is actually, we can go into this later, there is an Easter egg if you actually download the sample dApp that it's audio, and I'll leave it at that. But there are a few hidden Easter eggs in this dApp.
So what I'm going to do here is, so hence why you may see some names that are almost familiar. So this is just an app where I can buy things, and I can buy this non-fungible token, these non-fungible tokens, one for each of these cards, in exchange for the fungible tokens that I got before. So I am going to buy the baseball card for Anatoly Smorin, right? And again, you know, I'm not actually the baseball player in the family, but I understand these applications. So here now I get a proposal where this is a proposal to pay 10 fungible tokens, where I say I'm willing to pay at most 10 fungible tokens, 10 of the tokens that I got from the faucet, in exchange for a set of NFTs. You know, it's only one NFT, and then NFT is the NFT for Anatoly Smorin, right? So I can tell that it is the NFT type of the card store cards, right? So I have assurance of what that is. You know, I've named it card store. Well, card store, that's not very interesting. Let's see if I can, you know, this is really baseball cards, right? That's going to be my name for that application. Does that work? Yeah, there we go. All right, so baseball cards. Now, I've renamed the app. I've just given it a pet name of my own that lets me understand what it is. So when I go down here and I look at, oh, I've got a purse full that I can have baseball cards in, so I can collect them or send them to other people or combine them over time. I have an offer that I interacted with this application, and when I clicked on Anatoly Smorin, it told my wallet, hey, the user expressed interest in this. You might want to offer it to the contract in the background. I'm going to go ahead and approve that purchase of Anatoly Smorin. That will then submit the offer to the contract running on the chain. And you can see that it went through because this was an automated market. And so there was no sitting around in an order book or in an order book waiting for someone to come along and sell it to me. But if it was, there's a place where the outstanding offers would sit there so I could monitor them and see what the status was, exit them, cancel them, whatever. Right? And here you can see that I got now in my purse, I got Anatoly Smorin. Right? And of course I can do the same thing. I'm going to buy Raul Chamberlain. Yes, there we go. I want to buy that. You can see here I have the offer up here for Raul Chamber. Yes, I can't even pronounce it. I'm going to purchase that one too. And now you can see that my baseball card has these two assets in it, Raul Chamberlain and Anatoly Smorin. Now we have part of the secure components and architecture stuff and such like that will enable us to be able to provide dApp-specific UIs in the wallet, and we're working on those kinds of things with MetaMask and other wallet providers. That's not this. This is a very simple wallet that one of the things you could do, of course, as part of this hackathon is take it and run with it. On the left is a simple JavaScript, standard web application. On the right is a Svelte application using the Svelte UI framework. We also have a React application. All of it's the same kind of architecture. You can do an install of those, start with that for your application as a way to grow the next generation DeFi applications. All right, let's dig in to see how this works. So I'm going to go over to the same kind of contract. Let me close this thing here. And it's got the same kind of start. And whereas before I had a fungible token that I made the mint, here I'm just making a mint that says that the items are unique expressed by a string. We also have the items are unique expressed by an arbitrary JavaScript structure, or immutable JavaScript structure, and we'll add more as people learn new kinds of things that they will want to be able to distinguish their NFTs. But given denoms, it's astonishing how powerful you can get just being able to distinguish strings and talk about sets of strings. So the amount math for an NFT is approximately doing a set. That's why I was able to reuse all the same components for combining 1,000 tokens with 1,000 tokens into my fungible thing. I could combine Raul with Anatoly into my purse full of baseball cards, and almost all the same mechanisms work. Not all, but almost all. All right, so I'm going to let Kate take over exactly how this works because it reuses an existing component. We'll go into this for how it plugs together shopping, and then we'll look at the same pattern in more DeFi fine-grained transactional stuff.
Sure. So let's see. So what this contract is doing, it is, Dean, can you scroll down to the creator facet?
I certainly can.
So when you instantiate this contract, you get a creator facet back, and that creator facet has two methods on it. One allows you to be able to sell baseball cards, and the other allows you to get issuer, allows you to get the card issuer. So sell cards takes a few parameters. So there's an array of all of the new card names, and these cards will actually be minted within this contract. There is the money issuer, and this is the issuer for the type of money that you want to receive when you're selling your cards. And then there is the sell items installation. And so this is where the composability comes in, where you're able to use the sell items contract that has already been installed. And this is a contract that's within Agoric SDK, so you can feel free to look at that. But we're going to be actually instantiating an instance of the sell items contract. So we need the installation for that. And then there's a price per card. And in our dApp, we just set that price per card as 10 tokens, 10 of the fungible tokens that we got from the faucet. All right, so within this method, first we make the amount for all of the new cards. So we just take that array of names and we turn them into amounts. And then the second thing that we do is that we actually use that amount to mint the cards. So on line 29, this is the only time that cards are actually being minted. All right.
Oh, can I inject something here?
Yeah, go ahead.
Because when I saw this, I was also sort of delighted and surprised. This is taking that list of cards, which could be a list of whatever it is that you have as pre-allocated things, and it's minting the whole set at once. So I get a single payment that is the payment of here's the asset for all the cards. Now, it's important that if new ones got minted, every month there's a new set of cards, it would be straightforward to enhance it to mint a whole nother set and dump them into the same set of perps. But just being able to mint a whole bunch of NFTs at once was very cool. So anyway, just thought I'd share that.
Yeah, the way that this contract is designed is, if next month you wanted to come out with a whole new set of cards, you would be able to call this contract again, or call this method again without having to create a new contract. And it would sell those items for you. So if we go down to the proposal and the payment keyword record, so what we're going to be doing is we're going to first be instantiating that sell items contract that we saw, and then we're going to be making an offer to that contract. So so you can see that in line, let's see, it's 49. 47 through 49. We use the Zoe service. We call start instance on it. And this is actually creating the sell items instance.
And that's sort of a singleton instance of a reusable component that the app uses, or that that will then handle the transactions for individual NFTs. Is that correct?
Yep. And so then the next thing that we want to do is we actually want to make an offer. So this is taking all of the cards that we've minted, and it's actually putting them up for sale. So as Dean has kind of explained, and maybe you want to go further into this, Dean, an offer, it has give, so we're going to be giving all of the items that are for sale. And then it also has the actual payment of all of the baseball cards.
Let me jump for just a moment, because here it's using that mechanic in order to set these things up. And and an enhanced version of the sell thing might demand, I will give you these cards if you give me back some governance control over the sell process, or access to the intermediate funds that you're going to be selling, or a surety guarantee that you will not walk away with my cards. In the case of the application, a similar kind of, if I look for, where's an offer here? This is a test. So this is the test code for that contract there. And here, it is acting like the user interface, where it's saying, I'll give you money in exchange for the items, right? I'll give you enough to buy the baseball card named Bob, and what I want is to get the card back. And so that has both a give and a want. And it makes an offer, it has both a give and a want. It gets a payment that says, okay, those price per item, I'm going to go ahead and mint a payment for that. I'm going to extract money from my account for that. And then I'm going to make an offer that says, here's the offer, here's the payment. We'll go into that more, but I just want to distinguish the eventual end client that shows up to the UI has a want and a give. In the case of wiring with internal trusted elements, it might be simpler than that. Same with the faucet, was just a, hey, give me a bunch of money, or I want a bunch of money. Here it's, I'm giving you a bunch of baseball cards to sell.
Right, and we got a question in the chat about what the Zoe service is.
Okay. So I will explain that once we're done with this example. But it is the smart contract platform that's providing a lot of these assurances, and that's one of the most important elements. We'll get there in about 2 minutes.
Yep, and do you want to scroll up to where we get the Zoe service, Dean? That might be applicable here.
Yep. Mm-hmm.
So within the contracts, each contract has access to the Zoe contract facet, or ZCF. But you can also get the user side of things, which is called the Zoe service. And you can see, and can we go to the usage of the Zoe service again?
We can. Oops. Apparently we can't.
You can see that we use it to act like a user when we start the contract instance and when we make an offer.
Right. So contracts can act as users on other contracts. A portfolio manager could be selling on a market. In our case, we have a stablecoin engine that will automatically liquidate against an AMM. And in this case, we have the contract for selling baseball cards using the sell individual NFTs abstraction that's reusable for a wide variety of purposes. All right. So let's, anything else you want to say on this, or shall I pop back out?
I think we're ready to pop back out.
Great. As long as I was here on the test contract, by the way, I will go ahead and cheat. I'm going to change to the contract directory. And if I say yarn test, you'll see that it runs Ava. Ava is a standard high-end test infrastructure. And behind the scenes, it's kicking off a test. And that test is all of this code with several different assertions on the state of things that happened during this thing. All of our systems are of this flavor, and it runs for supporting TDD, where if you look at about a month ago, Kate did a Code With Us session for Cosmos, where she was running and doing development on the fly, where every time she saved, the unit test was being co-developed with the smart contract was being automatically rerun to see that everything was correct. And so being able to use standard development environment and standard tools is just a wonderful, wonderful thing. Okay, so that's our development environment. Let's now go back to the presentation and answer that question about the Zoe service. Okay, so first let me start with a little bit of background, where in existing platforms, right, I talk about how they've got security hazards. The security hazards are not just for you, the developers, but they're also for you, the users of these systems out there, right? So this was provided by our good friends at MetaMask, and this is a picture of real MetaMask on real ETH, where if I want to send Dan Finley money, I have to send it to my good friend 0x55E2. Right, and the thing that's wrong with this is, you know, that's not the name, so I have to have these other services, and I have no idea whether Dan Finley got there first, so that doesn't actually buy me anything at all. It could be an entirely different Dan Finley that I'm trying to send money to, right? And it's not just Ethereum that does this, right? This is the model across the world. This is the Looney wallet, and there, you know, in this case, it's to my good friend 1GHKM. Is that Dan? Is it Zucky? Is it the Unified DAO? I don't remember, right? And yet that's my user experience. And we have the same user experience for Uniswap, where I go through this lovely UI. You know, I pick my what I'm going to buy and what I'm going to sell. I click on a button, and then it says, "Did you want to send 5 ETH to 0x8437?" I don't know what the number is. Do you? Right? And the answer is, you know, the model of interaction of send money to a random number and hope something good happens is a dangerous, is a problem, right? It's something that all of us very early adopters can stand in the same way that we used octal dumps and looked at addresses to figure out what was going in our C programs. But asking, the accountant at a large company to deal with their spreadsheet by looking at the addresses of things in memory, which is sort of the moral equivalent, it's not going to fly. It's not the way we're going to be able to grow this beyond the relatively small community of innovators and get out to the trillions of dollars of financial markets out there. The key thing is, it's also not how people work. It's not how businesses work. I don't say, here's a bunch of money. Oh, look, I got some money. I got some assets back. I say, I will give you this money if you give me that thing, right? And so in our system, it's all about the offers, right? That's what's really going on is, I will pay you 3,000 moolah from my savings account. I might have more than one purse for the same currency, right? In order for you to give me, right? And what I want from you is 2,000 simoleons back. And that's the offer. That's what I want to be able to do. And we do that pervasively through our abstractions. And so let me tell you, so what happens? So Zoe, going back to Zoe Surface, Zoe is the framework. So there's just low-level executing of JavaScript autonomous programs to be able to safely run separate programs while communicating with each other. But the framework for our smart contracts raises it up yet one more level to provide what we call safety properties. I'll come back to that question about the wallet in a moment. So in Zoe, I'll go back to my auction example. If a seller wants to auction a concert ticket, a digital good, they make an offer that says, I will give you this concert ticket, but what I want is at least X moolah, right? You have to pay at least that much, and it's going into an auction, and so the auction might give it more money, but I need to have at least X moolah, or nobody gets the concert ticket, right? The other side, the clients are doing exactly the same kind of thing, but in the opposite direction. I will offer at most Y moolah in exchange for a concert ticket, right? And what Zoe does is the offers are made through Zoe. So that's why it was Zoe offer this invitation that says, yep, you're welcome to join the auction for this concert ticket, right? And if anyone believes that doesn't happen, then they didn't get signed up for a Tesla. Right? You're welcome to join the auction for a concert ticket, and you then present, here's what I want, here's what I'll give, and here's the assets I'm giving. But those assets get escrowed inside of Zoe. So it's not that the contract code gets your ETH and then screws up and gives it away to some guy you've never heard of. It's that the underlying contract infrastructure squirrels it away in escrow, but notifies the contract and invokes that handler that you saw in the code in VS Code there, invokes the handler to say, hey, an offer is here, and I've got the assets required for it squirreled away. Go ahead and process it. Right? And so then the contract code figures out what's happening. It does what we call a reallocate. So in the case of an auction here, at the point where the auction closes, it figures out who the highest bidder is, takes some of their money, gives it to the seller, takes the concert ticket from the seller, gives it to the highest bidder, and it does that all atomically. So that's a reallocate that simultaneously conserves the currency and satisfies the offer constraints of the two participants, right? So the seller is satisfied, but because the seller got at least X moolah out of that reallocate. The buyer is satisfied, the client is satisfied because he got at least a concert ticket out of that, at least one concert ticket that he desired out of that exchange. And so they're both satisfied, so the reallocate is allowed to proceed. And that checking of those constraints happens independent of the code. Oh, and then once that happens, then they exit and everybody gets their payouts. And so they get winnings if their offer was accepted, and otherwise they get refunds, right? So one of the things here is all of the losers of the auction, it's not that the contract had a pile of money and now it's got to divvy it up. That was all locked up in escrow and known to be associated with the particular bidders. So when those get exited, the infrastructure delivers the money back to the bidders in the form of a refund. And so the infrastructure guarantees that refund, right? So this is a property we call offer safety. And just like, this is like a software engineering safety property, right? So when memory safety came out, there was a whole class of bugs, of dangling pointer bugs and wild pointer writes and memory corruptions that you get routinely in C++ programs that in C#, Java, JavaScript, Smalltalk, Rust, a bunch of these things that are memory safe languages. It's not that those bugs moved around, they just went away. Right? You just don't get dangling memory pointers in a JavaScript application. It just doesn't happen. You get other bugs, but you don't get a whole new class of bugs. You just get that whole 80% goes away. That's what we call a safety property. Type safety, memory safety, concurrency safety. I bet there's a lot of programs that a lot of folks that lost money in reentrancy bugs in the DAO or in the parity lockups. Those were concurrency safety bugs that simply should not have been possible. Well, offer safety takes off the table another class a new class of business bugs that in current contracts, they're pervasive. What was it? Open, OPYN. They had to withdraw their put contract because it had a bug that is essentially an offer safety bug that simply should not have been possible. It should not have been something that had to be caught in review. It should not have been something that had to be, you had to be so smart that you could avoid this particular landmine. It should simply not have been possible. And so what offer safety provides to clients is the guarantee that they either get their desired payout, they get their want, or they get a refund, right? They get a full refund of the money that they put in, of the assets they put in, whatever those assets are. So if I'm the seller, I made an offer, right? I made an offer to the auctioneer. From that perspective, I'm a client of the auctioneer. I made an offer of a concert ticket for at least X moolah. If I don't get X moolah, then nobody gets the concert ticket. And that happens regardless of the behavior of the contract. It doesn't matter whether it's a bug. It doesn't matter whether it's deliberate. It doesn't matter whether they had a private key to let them upgrade it. Doesn't matter. None of that matters. The infrastructure of running smart contracts provides those assurances. And indeed, yes. So Suhail asked about whether offer safety survives crashes. And so that's what we call, not exit safety. What is it? Payout liveness. Yes, that's a liveness property. And so we call that payout liveness. And indeed, it does that. There is a more detailed presentation about Zoe that talks about payout liveness. And I'm happy to go into that afterwards. But absolutely, part of the reason that Zoe service is a separate infrastructure from the smart contract is no matter what happens to the smart contract, even if it has some unpredictable execution corruption because some element of the infrastructure that none of us knew about happened to creep in and such that that gets terminated, the Zoe service will ensure that the refunds, that all the offers are exited and everybody gets their refund. So you do not get a stalled, locked up $200 million in a contract like you see on a few contracts on Ethereum. not naming any names. And now the offer safety also ensures to the contract that the assets are synchronously available. Now, our model of the world and the necessary real world model of the world from our perspective is contracts are, have simple sequential transactional behavior in a sea of asynchronous communication. Ethereum has this overly simple model of complete synchronous integration that leads to the concurrency, safety, and reentrancy bugs, and they've already had to give up on that in order to do sharding. That's because the real world doesn't work that way, right? When you go through a travel application and you want to get a hotel for a vacation in a city and a train ticket in the same reservation, you don't get to lock up the German railroad site and Hilton in order to make your decision of what you're going to buy. You end up having to go through asynchronous interactions with these in order to put together a package that you can then atomically commit to. That's our fundamental architecture. And so what Zoe provides is when payments come in, whether it's the offer of the digital asset or whether it's wrapped Bitcoin brought in through Ethereum across Peggy onto the hub using IBC transferred over to the Agoric chain, Zoe will handle the escrowing, which is an asynchronous process, and it will then call the code once it's synchronously locked up and known to be available. And so what that means is the contract code that you saw that is so simple that just gets to know, well, do I have this much? Great, let me go do this thing. It's got a high assurance that those assets are synchronously available. That means it can synchronously do the reallocates, even if it's doing those reallocates against options or assets that are reserved on other chains. And it all just works. It all composes, and it means that the same contract components are usable for a bunch of purposes. And then finally, of course, it's checking, if I said I want Quatlus to buy this concert ticket, I don't have to write a bunch of that code. I want that kind of stuff to be handled by my infrastructure for me. So when, my offer was this concert ticket for Quatlus, figure it out, right? And if you're offering these simoleons, then the offer safety is not satisfied, and so the reallocate doesn't go through. And then finally, Zoe assures that assets will be delivered upon completion or upon error. Okay, so you saw a little bit of that code, but this is a little bit simpler, peeled out, pure example. If I've got an invitation, remember it sort of starts with an invitation. So hey, you can participate in this auction. I put together a proposal that's got what I want and what I'm willing to give. So I want at least seat E4. And if you give me bonus seats in the front row, great. Right? If you give me $5 to participate, great, whatever. Right? And I will give you at most 100 moolah. Okay, and this goes back to the exit criteria. And my exit is, if you haven't gotten me a ticket, I get to execute whenever I want, right? I get to exit whenever I want. That means no failure, no stalling, no infinite loops. Obviously we have gas, so that doesn't happen. But, contracts can take a long time. None of that happening will have any effect on me being able to exit. Okay. And there are other exits, right? We'll show a covered call, hopefully in a moment, where in the covered call case, it's not a covered call if I'm not committing to here's my digital asset that I'm wrapping with this contract. I promise in a way that you can verify that I can't get those assets out until next Thursday. That means you can rely on the covered call actually having those assets until Thursday. But after Thursday, I get them back if you haven't exercised the sale. Okay. And then I take a payment, which is exactly, I withdraw from my moolah purse the set of 100 moolah. Moolah 100 here is a shorthand we end up using in JavaScript to be able to declare the amount, which is not 100, it's 100 moolah, right? And then finally, I make the offer, where making an offer is I'm invited. Here's my proposal, and here's my cash on the barrelhead, right? Here's my assets, and whether that's the digital asset or the NFT or what have you. You're going to say something? Oh, okay, I thought I heard noise. Feel free to step in, Kate, if I get something wrong here. All right, and then finally, after it's all satisfied, in the auction case, it might be at a time close of business. It might be when the auctioneer feels good and ready. It might be once there's 100 votes. I mean, it doesn't might be when it crosses a certain threshold. Whatever. The auction closes. It exits my seat. Exit being voluntary or involuntary, whatever. Once my seat is exited, then any reallocates, any assets, they all get transferred back to me as in the form of payouts. And so hopefully if I won, those payouts are the concert ticket I wanted, but otherwise it'll be my 100 moolahs coming back out of escrow. So that's buying a seat ticket with an offer, and that's what the UI was driving. Okay. So let's go back and look at some more contract code. Now, I'm not going to do a UI in this case. This was the code that Kate built at the Code with Us session a couple of months ago. If I jump back here, let me find my. Here we go. It's on my other window, and I can't move my window. There we go. All right. So this is an OTC desk application, an over-the-counter trading desk. This was inspired by Hasib of Dragonfly Capital. He was talking about unbundling Uniswap, where if you come in and say, "I've got this thing to buy, what do you give me?" There are humans out, there are systems out there like, AMMs are one mechanism, order books are another. Over the counter desk means there's someone off chain that's got a decision process that will come back and tell you, yeah, I'll take that. I'll give you, for those, I'll give you this many atoms for that many baseball cards, right? So this is the contract that lets us do that. And the way that works is, as with the others, it's a contract. It gets the terms where it's also getting an installation of another contract to use to help finish this thing. And it internally has an empty seat. Okay, let me say something about seats, right? So back to the auction example. When I get that invitation and I make that offer, I get back what we call a user seat, which is the user seat is the object by which someone outside that made an offer can monitor what the status of that offer is. And all my examples so far, these things execute essentially immediately. I await the answer, I get my payouts, and I'm done. But it could be that I make an offer that's going to sit there for a month before being resolved. The seat is my seat that represents my access to the assets and the ability to cancel and the status and all that kind of information about that offer in progress. And so it is held, for example, as accessible to my wallet if I've got an outstanding offer that the wallet is tracking. Internal to the contract is what's called the ZCF seat. The ZCF is the Zoe contract facet. That's where when Zoe launched the contract, it made a nice little bubble in which the contract was deployed and gave it access to the outside world only through that ZCF, through the access to the ZCF. The ZCF seat is the object that represents an offer being presented to the contract in order for it to be able to support, right? In order to be able for it to respond. So for a given invitation, there will be a handler. When the invitation is exercised, the handler will be invoked with a new ZCF seat that allows the contract to control and monitor the status of the associated offer. Okay. And so one of the things a contract can do is if it's got internal liquidity pools or bank accounts or governance tokens or whatever it has, it can have internal seats that it manufactures just for the logistics of the contract. In the case of an OTC desk, it has an online inventory of the stuff it's willing to trade. So if we're trading, well, I'll just use two fungible tokens, right? If we're trading atoms for a local stablecoin, it'll have a pool of both of those. So when you say, I want to sell atoms, it can, if it says, great, I'll give you, 500 what's the thing that doubloons? Yes, that's the thing that a few people 500 doubloons for those atoms. It'll, if you decide that, it'll pull those atoms, those doubloons out of its account and hand them to you, right? So that's the market maker seat. We get the Zoe service as above. Now, the thing that the creator will need to do, this is the person operating the over-the-counter desk, right? The person that's going to make a quote and provide it to you, the person that wanted it. They're the ones that have the authority to move money into inventory, move atoms into inventory, manage the inventory of the OTC desk, and to make a quote. And so the operation we're going to look at is the make a quote operation. And I'll take about 5 more minutes on this and then we'll pop back out here. So the make a quote operation is what I, the operator of the OTC desk, will do when you come to my web app and say, I would like a quote for my 500 atoms, right? 50 atoms, whatever it is. And this is where you want to take your cash winnings from making an awesome DeFi application, your atom winnings, and go and convert them into some other token on some other chain so you can engage in DeFi and get even more atoms, right? Okay. And so what this is going to do is instead of doing all of the work of handling the sale and all that sort of thing, since you've never heard of my over-the-counter desk, you don't trust me, I don't have a reputation, I'm not out there, it's brand new, but you want to be able to get a quote. The way I'm going to provide that quote is by instantiating a covered call option that has the assets of the quote in it, right? So covered call, a call option is where I give you an object that has an exercise operation on it, where if you exercise the option, you can buy the thing in the call. So here you can, here's an object that until next Friday, you could buy the concert ticket underneath for 50 atoms. Okay, it's an expensive concert ticket, right? And if you haven't bought it before next Friday, then I get the concert ticket back, and then you can't buy it anymore. But you have this until next Friday. That's exactly what we want as a quote. So the quote of atoms for doubloons would be a covered call where if you said, I want to sell this many atoms, great, I will give you a covered call that if you exercise it by providing it that many atoms, then you will get this many doubloons. And it's covered in that the promise to give you this many doubloons, those atoms are actually, those doubloons are actually wrapped up and escrowed inside of that contract. So I no longer have them in my inventory. They're in that contract. So you, without trusting me, you can verify that you got a legitimate covered call built from an installation that has been there for years, okay, DeFi years, so maybe the last 3 months, right? That's been there for the last 3 months under heavy usage, heavy attack. It's used by multiple different applications. And it's exactly the thing that you expect. If you get that back, now you have an assurance that you got a legitimate quote, right? Now you've got a quote that you are willing to accept that clearly has the assets underneath, that clearly expires no earlier than next Thursday, or actually in the case of an OTC desk, more likely no earlier than the next 15 minutes, so that your automated system can look at a bunch of quotes and decide which one you want to take. Right? And so we're going to start an instance. This is a brand new covered call just for your request. And it is in terms of the issuers that the OTC desk is trading, so atoms for doubloons. And the offer that the quote maker makes as effectively the seller into that asset is it's saying, I will give these assets this many doubloons, and what I want is this many atoms. And I am committing to have it not exit. Basically, it will only exit after the deadline that this quote was for. So I, as the operator, said, I will give a quote that expires in a half hour. That's the deadline according to a time authority that might be the current block height or the block height on the Cosmos hub, or clock time as reported by this service, whatever oracle for time I put in, that's that time authority. Right? And that's my proposal. That's what I want to produce. I then, but I need to actually have the doubloons on the barrelhead and bury it into this brand new contract in order to be able to make that offer, because the contract is not covered without that. So I withdraw from my market maker seat those assets that I required. I then make the offer to the covered call invitation, right? I've got an invitation to participate in the covered call as the initiator of it. I make that offer. And the response to that offer is, in exchange for locking up my tokens for that period, I get back the seat. One of the things I can get from that seat is the actual thing to be able to sell. So I get the offer result of making that offer. That's the return result. The return result of making an offer might be, an object, an arbitrary JavaScript object, or something that I can do remote operations on. In this case, it is the counterparty invitation. So I create the covered call, I hand it the initial assets, and what I get back as the result of that is the invitation I can send to you as the quote. And so that's what making an offer will entail. I, as the creator, am the only one that have access to saying make quote. So now I can operate my service where I'm going to make quotes. Right? And this covered call invitation is an example of one of those reusable contracts, right? It is in the source code tree. I'm sure that somewhere here I probably have, oh no, I don't on this machine, I have it on the other example here. I will come in here, and it is in our source code tree as, there's a covered call, and it too is a very simple expression, right? It's a contract that that has an exit after a deadline, and the fundamental operation of the thing that after I've made this contract, I'm going to return an object that can do an exercise, right? So when you get the quote and you decide to exercise it, I'm just going to swap the stuff that you provided for the stuff that was being sold. That's all that has to happen. That's the entirety of a covered call. All of the issues around expiring on the date, all that sort of stuff, they're handled by the infrastructure automatically. And so most of the rest of this is the construction of that core thing that I can provide to you that lets you exercise it. Okay, and this is the reusable covered call abstraction that multiple applications use in order to be able to provide that kind of service. Okay, so that's the dApp. And again, you can go deeper into this by looking at the Code With Us session, and that shows you going through the actual process of building this. An important element of that is, again, you're building it in the context where as you do these various operations. Oh, this is the other one. There we go. Right. Again, if I do, what are the operations available to me on this object? I get the standard kinds of things one expects out of a JavaScript environment with TypeScript types behind the scenes and that sort of thing. Okay. Let me now wrap this up with a few more big points. So again, what Zoe provided for clients, the mechanics of it is, I as a client start with an invitation. I make a proposal. I put together a proposal with the assets in order to make an offer. And I get back a user seat that lets me control that over time. So you're going to be doing this in your code, in your app code. And you'll see that in the app code, in like the UI code or the application side. The API server side does this on behalf of the UI. And then finally, when it all resolves and the seat exits, I get payouts. The payouts being whatever it is that in my proposal, I said I wanted, or a refund, and I can sort those into the appropriate purses in my wallet, and that happens, that's what the wallet does for you. But those are the key concepts that clients get. The corresponding elements, and then the key thing is they receive their desired payout or a refund, and that's sort of the fundamental safety property that they get. For contracts, the steps are, I have an offer handler that will be invoked. An offer handler is associated with the invitation I got out. When someone makes an offer given that invitation, that particular offer handler will be invoked. That means it can close over a unique state for that offer handler that the creator of that invitation decided to set up. So I can give an offer to one person of one price, an offer to a different person of another price. The offer to participate in a faucet can be 1,000 for people coming from one channel and 100 for people coming from another channel. And so being able to distinguish, even for the same behavior, different parameters for how I'm going to handle that offer is very powerful. Internally to the contract, when the offer comes in the handler, you get a ZCF seat to be able to synchronously manage access. Once the contract decides what it's going to do, and it might be that it looks over an order book and decides that these two outstanding offers match each other, I'm going to sort them. It does that reallocate. It could be a multi-party offer that if I sell him X, sell him Y, and sell him Z, and there's a whole dependency rotation, I'm atomically going to do that in-party trade. Reallocate can handle that. And it can handle that while checking and preserving and enforcing all of the safety properties. And then finally, exits happen. And as a result of exits, all the payouts happen. Okay? So those are key mechanics I wanted to make sure you were familiar with. There are a wide variety of sample contracts that are available in our documentation. There are pointers to the documentation will be posted in the channel and available off our website under Alpha. And also off the HackAtom site. And we will have office hours every Tuesday and Thursday with multiple of our developers available live there. And often we will be available in our Discord support channels day and night across a wide variety of time zones. But the office hours where we're present is 4 p.m. UTC. For me on the Pacific, that's at 9 a.m. Pacific time. And we are happy to hear from you, happy to help you to succeed in putting together both reusable components, using the existing ones, extending them, growing new ones, and putting together dApps, leveraging the UI plumbing and reusing all of the UI frameworks and wallet integration and so forth. and there's other documentation about each of those pieces available to you, and we're happy to help you through that. So we look forward to making DeFi even more exciting and a whole lot less dangerous, and helping you win awesome prizes. So dive in. We'll be around for questions. I'll be around for 10 more minutes, and then I prepare for another talk. Kate will be around for longer than that, as are much of the rest of the engineering team.
Thanks, Dean. We had one quick question, if you still have time.
I do.
So we got the question, are there things one shouldn't do in a contract? Where should the code that makes calls to off-chain resources live?
Right. So those are great questions. So the execution model, one of the things, I say a secure version of JavaScript, but it's not just a secure version of JavaScript. Let me stop sharing my screen for the moment. I say not just a secure version of JavaScript, but it does essentially deterministic replay. So on each of multiple validators, the same contract is being run exactly identically, coming up with the same answers. And if if something crashes or I'm starting up a new machine, it just plays the transactions all from the beginning, and it will get to exactly the same place. Or it plays it from a checkpoint, and it'll get to exactly the same place. Right? Checkpoints is something that will be in beta. It's not in alpha, just by the way. And the same mechanics works for the API servers as host machines. So that does mean that contracts natively do not get access to things that are not deterministically part of the blockchain environment. And indeed, getting time is an Oracle question. Now, oracles are a generic problem. We will talk more about how we're going to make the Agoric chain next year an information-rich public blockchain as we roll out in 2021. But it is a generic problem where many of the oracles are native to the chain. In particular, block height, from our perspective, is an oracle that your contract may or may not have been deployed to be allowed access to. So if one of the things you want to be able to provide strong assurance to customers that you do not have available as a the block height, that will just not be a capability that was provided to your contract. That means it can't get it unless someone who has it gives it to them, right? That's one of the fundamental elements that provide security and nice, strong composability. So time is an oracle. Many contracts will have that. There is a timer service. There is a abstract architecture of a timer service, so we will have time available on our contracts. But with IBC, we will be able to have time oracles about the block height on other contracts. We'll be able to have time oracles about the current block height of Ethereum. If what you're trying to do is bring Ethereum assets over Peggy into our interesting, more extensible, richer markets, trade on them according to some contract over some time that's associated with Ethereum. Once that market activity and DeFi activity happens, you might end up wanting to redeem over there or signal that some transaction happened at some particular block height or what have you. And so that's all part of that infrastructure. Obviously, things you should not do in a contract: run an infinite loop, allocate an infinite number of things. There will be metering that will then kill your contract because you overran these boundaries. Yes, we certainly have time. And the mechanics, the simple mechanics for talking to external websites or talking to the cloud service for your application is this mechanism where we have, it is a, let me see if I can go to the slide, right? The overall architecture is of large-scale distributed systems, right? Remember, we were working on this stuff years before blockchain was. The overall architecture is you have a public chain with replicated execution. It's using IBC to be able to talk to other public chains, other potential instances of Agoric that extends out, where this might be a private chain or a consortium chain, or it can be my individual machine, right? And so the code running over here can be running on individual machines, and if it's running on my individual machine or my small cluster, that may have authority to access, assets inside my organization, or send email, or talk to a local SQL database, or whatever it is. But you can't do that from chain contracts. Okay. One more question, if you have time. Can I use native Cosmos modules in Agoric, or should I use IBC? The answer is yes. So we have some integration to native modules in Agoric, but they don't expose up sort of as sort of arbitrary Cosmos stuff, because this system is largely agnostic, because you want the same contracts to be able to run in a private machine running in a cloud to be able to coordinate. So in the example of the OTC desk, it's an OTC desk contract, but I might want that to have access to private data and pricing information and AI that's going to rapidly decide exactly what price to offer. In that example, I just had it up. I can share it again. In that example here, right? This OTC desk, the OTC desk contract would be executing on a side chain, running our very same model, running exactly the same contracts, connected with IBC to the public chain. This is a side chain that is a coordination of a bunch of brokers that are trying to cooperate to provide, or a bunch of market makers that are cooperating to provide this OTC desk. But when it produces the covered call contract to represent a quote, it is instantiating a new covered call on the public chain just for you. So it's not a covered call over here running on their machines, because that doesn't have integrity. You wouldn't trust that, interestingly. It doesn't provide you any assurance. Running over here on the public chain, their contract off-chain, asynchronously coupled with our distributed object over IBC, their contract off-chain can instantiate the on-chain contract, and in a way that your exchange would, using like the once in another Zoe offer in some broker application that talks to a bunch of different OTC desks, that system would be able to automatically verify that, oh, it's a legitimate covered call, it's got the assets you want, it expires at the right time, it's good. I will give you that as part of this contract. Okay, does that answer your question? And thank you, those are great questions, Sale. All right, so, and back to the other question about how do we get a random number. So indeed, getting random numbers is an Oracle question. There are good, strong ways to do it. There are people that are expert at that. Turns out, since the history of random numbers, since the history of computer security, one of the major weaknesses is if you have something that's relying on random numbers for a security property, and it's not actually securely random. If you're doing gaming and you're relying on it for gaming, that has other requirements. So being able to have multiple sources provided by the experts at those, and have those as a reusable component, so you don't have to be the expert in order to be able to compose and get a real random number that you can count on for whatever characteristics you have, that's huge value.
Do you want to talk a little bit, Dean, about the code that you need to run your dApp, but that should not be in a smart contract? So the code that's in the API folder?
Yes, I can say a little bit about, actually, what I may do is let you take that over, and I will jump to the, well, no, go ahead. Here, let me share my screen. I have a minute here. And I can go to the, which you prefer, the baseball cards or the faucet?
I think either is fine. Okay,
here's the API server for one of these, doesn't matter which. And in the API server, it's of course JavaScript. It has a handler where the core element. Well, do you want to talk to this if I get something wrong here?
Sure. So this is the long-running handler. So the dApp UI will make requests, and this responds to those requests. And so this is where the invitation to the user is actually being sent. So if you have code that you need to run that doesn't need to be run on-chain or shouldn't be run on-chain, this is where that code would live.
Mm-hmm. And fundamentally here, it's set up where these on-message are being invoked every time the UI sends a message. And the nice thing is, from the architecture of this handler, I'm looking at the handler, right? From the architecture of this handler, right, this can be sending asynchronous messages that look just like the contract-to-contract messages or the server-to-server messages. It's communicating these asynchronous messages over to the blockchain to get responded to. So it'll post it can make an offer here, right? And indeed, maybe one of these does, right? Somewhere here, right? And so it makes an offer. It can do it and wait for the answer. When the answer comes, so here this is waiting for the result of receiving an invitation, and then it sends a message up to the UI to update some part of the screen, right? And so being able to have arbitrary asynchronous plumbing that works well with all of your standard browser to cloud services mechanisms is lovely. Does that make sense? In our apps, we use WebSockets, and our communication happens over WebSockets. In some cases, it's just standard JSON invocations getting message blobs back, which is what you see here. In other cases, we've extended this distributed object invocation where I can send messages asynchronously over the wire, like this is calling make invitation to the creator facet that's on chain. This could be sending a message asynchronously up to the browser, where it gets back a invitation that it awaits, or the result of an update from the browser, or what have you. All of these kinds of plumbing can coexist. You can have apps that work different ways. All right, well, let me take us back to our exit slide. Please make sure to check out the hackathon. And go to this Discord during office hours if you have any questions. Or, of course, you can also check with us at our Agoric Discord, inspired by the Cosmos Discord. There's an Agoric area that connects off to a separate Agoric Discord if you want to dig farther in over time outside the hackathon. Thank you all very much, and we look forward to seeing you online.